Here goes, finishing up this last little bit of section 8.1. So where we left off is we were in the plane, and we determined at the very beginning when we started talking about planes that two lines in a plane that don't touch are parallel lines. These two blue lines right here are parallel. That means they stay the same distance apart no matter how far away you go. And then I had told you that because math people like to define everything and give everything fun words, a line that cuts through two parallel lines is called a transversal. So this pink line right here on the figure is called the transversal. One of the reasons we mention it is because now it creates all sorts of angle relationships for us to take a look at. And so we're just going to spend a little time talking about those and seeing what happens. So our first angle relationship. Now, this first angle relationship is not particular to parallel lines, but it was just a good place for me to include it. Angle 1 and angle 4. So these two right here that are directly across from each other, they share a vertex and are right across from each other. They are called vertical angles. And vertical angles are equal. In fact, all of these relationships are between angles that are equal. So angle 1 and angle 4 are vertical angles. So there's other pairs of vertical angles on this sheet. Who can tell me another pair of angles that are vertical? Yeah, sure. 5 and 8 down here. They share a vertex and are right across from each other. So angle 5 and angle 8. Great. I'm going to put a little comma because there's another pair if you can identify them. Sure. 2 and 3. They are directly across from each other. They share a vertex. So angle 2 and angle 3. And then there's one more pair. I'll give you this one for free. Angle 7 and angle 6 down here. Those are all vertical angles. So again, I just want to reiterate, you can have vertical angles where you don't have parallel lines. In fact, when we talk about today's section 8.2, we're going to use that relationship, but it was just a good time to mention what vertical angles look like. These other three relationships are particular to parallel lines. The next one, angle 1 and angle 5. So notice angle 1 is at the top left corner here of these four angles, and so is angle 5. It's at the top left corner of these four angles. So since they sit in the same relative position to the two parallel lines, they are called corresponding angles. And I'm sorry for the short blank right there. I need to make that one a little longer. But angle 1 and angle 5 are corresponding angles because they sit in the same relative position. Does everyone see why those are called corresponding angles? Well, here, you're going to get your chance to prove it to me. What's another pair of corresponding angles between those two parallel lines? Yeah, 2 and 6. This is the top right. So angle 2 and angle 6. I'm going to put a comma because there's another pair. What's another pair of corresponding angles? Yeah, bottom left, 3 and 7. They are both on the bottom left. So angle 3 and angle 7. Bless you. And then there's one more pair. Call it out for me. Sure. Angle 4, angle 8, or angle 8, angle 4, doesn't matter what order you do these in. Those are all different pairs of corresponding angles. Corresponding angles, when you see them, they are equal. Doing okay? Everybody identify those four pairs of corresponding angles? Okay, if you can't, let me know. I can try to explain it in a different way and hopefully make it a little more enlightening. Okay, the next one, angle 1 and angle 8. So notice we've got our transversal. Okay. So there's two sides to the transversal. There's the left side, there's the right side. So notice angle 1 and angle 8. Angle 1 is on the left side of the transversal and angle 8 is on the right side. Because of that, angle 8 are called alternating. Leave a little room. There's two words you're going to put in here. Alternating. And then angle 1 and angle 8 are both on the outsides of the parallel lines. Okay, so angle 1, according to the orientation of this picture, angle 1's on the top, angle 8's on the bottom. So because of that, they're called alternating because they swap sides of the transversals, and then exterior angles because they're on the outsides of the parallel line. There's one other pair of alternating exterior angles. Yeah, 2 and 7. 2 is on the right side of the transversal, 7 is on the left side, and again, they are both on the exterior of the parallel lines. So angle 2 and angle 7 are also alternating exterior. And then 3 and 6. Well, 3 and 6, again, swap sides of the transversal. 3 is on the left, 6 is on the right. So again, we're going to start with the word alternating. So the word alternating is referencing their position with respect to the transversal. And then 3 and 6 are now inside the parallel lines. So they're no longer called exterior angles. They are interior angles. So 3 and 6 are alternating interior angles. All right, well, given that, one final time, what's another pair? There's one other pair of alternating interior angles. Yep, 4 and 5. Yep, they alternate sides of the transversal, left and right, and then they are both on the inside of those two parallel lines. So angle 5 and angle 4. Perfect. So all of those 4 different relationships express equality between the angles. And so here's the last exercise. I love to put a little exercise like this on the test. I hope you'll find it to be nice and relaxing and straightforward. So in exercise 5, I've told you that the measure of angle 3 is 25 degrees. So angle 3 is right here. I'm just going to put a 25 right there. And so now you're going to help me, and we are going to define the measure of all 7 other angles with all the tools at our disposal from this section. So who can tell me the measure of one of the other angles? Why is 6 25 degrees? You're right. Perfect. Angle 6 is the alternating interior angle with angle 3. So it as well is 25. Great. Now, some of these angles, there are multiple reasons. You only have to give me one. What's another angle measure here? Okay, what's 7? It's vertical with 6. Yeah, so it's 25 degrees. So you could have said for angle 7, one of 2 rationalizations here. What I was told is that these 2 are vertical. That's why they're equal. You could have also said that angle 7 is corresponding with angle 3. Okay, so there's more than one rationale. Okay, I'm only looking for one. Who can give me another one? Okay, 2 is 25, and there's actually now 3 reasons. You could have said it's vertical with 3. It corresponds to 6. And it's also alternating exterior with 7. So any one of those relationships would satisfy. Okay, so now we're missing those other angles. How can we figure out one of those other angles? Yeah, 180 minus 25 will give me number 1 because those 2 things are supplementary. They form a straight line. So 180 minus 25, what's that, 155, I think? Great. And with the same rationalization, I mean, there's lots of different ways you could do this for each. I think there's like 4 different for each of them. Angle 4 we know is 155. Tell me one of the reasons why angle 4 we know is 155. Sure, it's vertical with 1. Great, nice and straightforward. You could have also said it supplements with angle 2 or angle 3. There's another way. So great. How about angle 5? What's the reason, or one of the reasons, just give me one, that angle 5 is 155? Sure, alternating interior with 4, corresponding with 1. Either one of those things, if it occurred in your brain, would have been a great thing to say. You could have also said it's supplementary with angle 7. And then last but not least, angle 8. It's vertical with 5. It corresponds to 4. It's alternating exterior with 1. There's lots of different things you could say for that. All right, I'm done with what I have to say. Does anyone have any question, comment, or concern before I end the video? Yeah.